In section 15, activity 1, we are asked to write the equation of a line in what's called point-slope form. Point-slope form, in order to do that, we need to have two things. We need to have a point and a slope. Now, the point-slope form is this guy right here. Y minus y1 equals m times the quantity x minus x1. Now, the reality here, x1 and y1 are the points that we're plugging in, and m is the slope that we're plugging in. This y and this x are going to remain. However, we'll see later that it's not necessarily y's and x's we're dealing with. It's more of an output and an input. So in question number 1, part A says compute the slope of the line which passes through both given points. Part B says write an equation of the line in the form y minus y1 equals m times x minus x1. That's the point-slope form. And then rewrite that equation in y equals mx plus b, slope-intercept form. So in other words, we're solving for y. Alright, so in the left-hand side, we have these points x1, y1, and x2, y2, negative 2, negative 5, and 3, 5. First thing we need to do is find the slope. So we need to find the change in the y's, or the outputs. So go from a negative 5 to a positive 5 is a plus 10. And then find the slope, or the change in the x's, or the inputs. So going from negative 2 to 3, we have a plus 5 for our change. Our slope is the change in y over change in x. So our slope will become 10 over 5, which will reduce down to 2. To write the equation in point-slope form, we're going to choose this point x1, y1, and our x1 is negative 2, and our y1 is negative 5. And we'll plug those into the appropriate spots in the formula, as well as our slope, which we know is 2. So we're going to take that negative 5 and plug it into here. You'll notice in the formula it's subtracting the coordinate. So if we subtract a negative 5, it ends up being y plus 5. And then we have our 2 brought down from our slope, and then the negative 2 for the x minus negative 2 becomes x plus 2. Then we can take that equation and we can solve it for y. So when we solve it for y, we're going to distribute the 2 to both to the x and to the 2, making it y plus 5 equals 2x plus 4. And then we're going to take that negative 5 and bring it over to the other side. And what we'll end up with is y equals 2x minus 1. And I'll show you that in just a second, but it's kind of hidden here by this little menu. On the other side of the grouping, we chose the other point. Notice the equation looks very similar. We still have x's and y's that we're dealing with. We have a y minus y2 equals m times x minus x2. And it's still point-slope form. But now we're going to pick a different point. We're going to pick the point 3, 5. So when I pick the point 3, 5, you'll notice that the initial equation, the point-slope form, does look different. We have y minus 5 equals 2 times the quantity x minus 3. We can distribute the 2 to the x and the negative 3 and bring the 5 over. And you'll notice at this point that our two equations, once we've solved for y, are identical. That still happens in example number 2. We're going to use these points here, negative 1, negative 4, and 1, 4. Calculate the slope first, it becomes 4. And we'll use that slope for both sides. On the left-hand side, we're going to pick the point negative 1, negative 4. So we'll end up with this equation in point-slope form. Rearranging it, we distribute the 4 and then bring the 4 over subtracted. We get y equals 4x. And on the right-hand side, when picking this other point, 4 and 1, when I plug those in and rearrange for y, I end up getting the same equation. So no matter what I do, if whatever point I pick, as long as I'm consistent, I can't mix and match. I can't say I'm going to take the negative 1 from here and the 4 from here. As long as I'm consistent, I will get the same equation when I rearrange for slope-intercept. And there's the work for number 3 as well. Again, same pattern that we're noticing here, that once you solve for y, your equation is exactly the same thing. And same thing for number 4. In activity 2 from that section, the first part we're asked to match the graphs with the equations. Now the key to this is being able to pick out two key pieces of information. One is the point, and the other is the slope. So you'll notice in number 1, when we picked out the point, the x coordinate is attached here, but it says x minus 4, And the reality is the coordinate that we're using is 4. Over here, y minus 4, the y coordinate that we're using is positive 4. It seems like we're changing signs. So if I look here at number 5, I'm just kind of moving over so you can see. X minus 3 becomes 3 for our x coordinate. Y minus 1, we turn that into a 1 for our coordinate. The reason we're doing that is because we're actually subtracting the coordinate from x or subtracting the coordinate from y. And in order to get a minus 3 here, we had to subtract a positive 3. And the other piece we need to pick out is the slope. So here we go. The slope is the number right in front of the parentheses. It's 1/2 and negative 2/3 and so on. So the goal here is to match up the graphs with the equations. And the way we're going to do that is first start looking at the point. So I looked first at number 1 and figure out which graphs actually had the point 4, 4 on the graph. So I looked at 4, 4, and that's 4, 4. That's definitely not on this graph. 4, 4 is definitely not on this graph either. 4, 4 is on this graph. Not on that one. Or that one. Or that one. So we get to the point now where there's only one graph that goes to the point 4, 4. It has to be C for number 1. Alright, then let's take a look at, the other ones are kind of like this, but there's one I really wanted to focus in on. And that was number 2. So on number 2, we see the equation y minus 0 equals negative 3/4 times the quantity x plus 4. So we're going to take the point negative 4, 0. Again, the opposite of positive 4 is negative 4. And then 0 is just going to go into there. And our slope is negative 3/4. So if I follow that strategy that we just used for number 1, and I look at the point negative 4, 0, it's not on A, it's not on B, and I might think immediately that's on C, but I have to do a little bit more legwork here. I've got to double check this one, and here's why I needed to do a little bit more, because it's actually negative 4, 0 is on both of those graphs, both of those equations. So from there I have to eliminate and figure out which one it's going to be. Well, my slope for number 2 was a negative 3/4. What that tells me is the graph is falling from the left to the right. C does not fit that bill because as we move left to right, the graph's going up. But on F, as we move left to right, the graph is definitely dropping. It's descending. It's decreasing. So that one would be the right answer for number 2 because it's going through the point negative 4, 0 and has a negative slope. In this case, negative 3/4. So there's the answers for the remaining graphs. Again, we're going to follow the same process to solve those. On the back, the top part of the equation, or the worksheet, says given the slope of a line and a point which lies on that line, find the coordinates of 2 other points which lie on that line. And write your answer as ordered pairs. The reality is there's a lot of different ways that we can do this, but probably the easiest way is to just look for patterns. And we have a pattern given to us. It's the slope. The slope of, in the coordinate plane, will tell us how the x change, or the y changes, the output, compared to how the x changes. So in the top, what we have is we have a change in our y coordinate. So this guy right here, this positive 1, is our change in our y coordinate. Down in the bottom, we have our change in our x coordinate. What that tells me then is if I want to get another point, I can add 1 to the y coordinate and also add 2 to the x coordinate at the same time. So from negative 3, when I add 1, I get to negative 2. From negative 2, when I add 2, I end up getting to 0. Directions say we want 2 other points, so we're going to repeat that pattern again. Go negative 2 and add 1 to get negative 1. Go from 0, add 2, and you get positive 2. One I wanted to look at was number 11, because on number 11, things work out a little bit differently for us because we don't actually have a fraction at all, but we can create one. A slope of 1 means we have a slope of 1 over 1. My change in y is 1, and so is my change in x. So when I'm looking for the pattern, I'm going to add 1 to y to get 0, and I'm going to add 1 to x to get 4. And then I can repeat that process. It works much better than having to write the equation in point slope form and then randomly picking values of x to plug in to find out the matching y coordinate. And the last chunk was actually graphing. So to graph these, again, we want to pick out what the point is and pick out the slope. This is kind of what we did on the front worksheet of activity 2. But now we're actually going to put this on the graph. So in number 13, I picked out the point -2, -3, because it's the opposite of the x and the y. And that's where I began my graph. I put a dot right there, a point. And then my slope is 1/2. And what that means on my graph is my vertical change is a 1, my change in y, and my horizontal change, or change in x, is a 2. So every time I go up 1, I have to move to the right 2. So that gives me another point. I can move up again and move to the right 2 once again. Now in some cases it may be easier for us to distribute and solve for y, to get y by itself and graph it that way. But in a case like number 14, that would probably be a really terrible choice. We'd have -2/3 times 5. That's going to give us -10/3. Then we're going to have to add 4 to both sides. We're going to give us a fractional answer for that. 2/3 will be our y-intercept. And then how do we use this slope of -2/3? I mean, if we're estimating where this y-intercept is, then all the other points here are probably not going to be as accurate. So we want to be extremely careful with this, and using point slope is a pretty nice way to actually just go ahead and graph.